Okay, I think we are live. hmm Let me check. Yes, we are. Okay, nice. Nice. Guys, we are live. Uh, Now, what's the agenda today? What's that? No way. No way. No way. No, my machine cannot handle that. Stop recording. Yep. Okay. So, what's the agenda today? I have to work over adding concurrency support for rs-stl. So yeah, that's the total agenda. github.com/this, right? And yeah, should I go in source or something? Uh, so for slices, I was able to implement split at mute kind of function that can split a slice into two slices by consuming that slice, right? Now we are done with this. What I want to do is uh, adding concurrency support, safe concurrency, right? So how will we do that, right? Mm, that is the first thing I need to answer to Dave for a while. Mm, let's see how that goes. Do I have DMs? Got it. Yeah, the core problem that I do not remember what is the core problem. So let me try. Um, and WAM, right? And hmm, right. What I can do is I can have a struct and okay. So I need a trait lending iterator, right? And type item A, okay, where self is A and pub fn next, and that returns self item of this thing. So that's a lending iterator, right? Hmm. Mm-mm-mm. Wow. Yeah. So yep, that's a lending iterator. Now here's the thing. Mm, what I need to do was what was I doing here in the message? Filter adapter, right? For lending iterator. So struct filter, right? And uh, yeah, for I where I is a lending iterator. Mm, Publisher I, right? And I need filter based on some function. So where f is basically a function of I item of this thing, right? And Yeah, that's it. And that returns bool, right? And pub fnf, okay. I should call it predicate, right? Now impl, I guess even for f I can write like f is fn I item this thing, right? Now impl, uh, lending iterator for filter I and f. What I need to do is I need to implement the uh, item, right? Now item is same as base item, and for here I think I was writing this code, right? And self dot iter dot next. Hmm, hmm. Oh, okay. Uh, so return type is different. I guess even if I do this thing right, then that thing is yeah. This predicate should return bool. Okay, nice. And mm-hmm, mm, self dot iter dot next, right? I guess right. Self dot item. Mm, and it has some problem. Yeah. Uh, mm, cannot forward iterator as mutable. Okay. More than once at a time. Uh, okay. Mm, even if I do this, Uh, yeah, what's the problem? Uh, cargo test. This builds. So, yeah. Hmm. Mm, why filter need Polonius? Why lending iterator filter need Polonius, right? So, hmm. So for answering Dave, I guess uh, no, it is because of using because filter makes next call multiple times and filter makes next call multiple times, and what's the other thing? That filter makes next call multiple times. Uh, and call to and no loop, and also calls predicate with borrowed item, lending iterator, item is lifetime dependent parent, right? And also calls predicate with borrowed item, right? uh, Now now current borrow checker cannot understand that once predicate, because next call is next is a mutating function, uh, multiple items cannot exist at a time, and now currently rushed borrow checker cannot understand that when predicate use item ready when call to predicate happens, item. So much longer. Mhm. Follow Polonius. Uh, okay. Okay. The new experimentable. Click confirm. So if get thing get thing is a thing. Mm, well, what's that? Polonius. Polonius. Rust Polonius, I guess. So, so Polonius update, Polonius grab. What is Polonius? Okay, okay. Our first example is this one. Data log, region variables, relation between regions, point in flow graph, right? Borrow regions, live regions. Temp dot maybe next borrows start temp. This returns sometimes through it and then store. This means if you trace it out that indeed the borrow is live around the loop, you might think it will be killed because we reassign temp and it should. Temp is basically some v. So if case item is returned, not in else case. article says that when called to it was mutably borrowed. Oh, let me. Checker. Uh, hmm, into the log. Hmm. Anyways, we are quite done. Yeah, we have an hour left, and I have to do some work with uh, I have to do some work with rs-stl, right? So, anyways, let me try. Right. Let's see. So, what I need to do with rs-stl? I think what I want is the position should always be comparable, right? So if I go in core, right, uh, position should be ordered, always ordered, right? So random access collection, right? Uh, the position need not be ordered, right? Uh, because position is ordered by default, right? Now, uh, here's the thing that uh, because position is ordered by default, I do not know. What about the range of int and things? I think range of int and all are quite ordered things, right? And yeah, uh, it works for range of int and all. I think it doesn't work for reversed the way it is supposed to be, right? So for reverse, where P is partial ordered, I guess even for this it works, or I don't know, right? So let me try doing a cargo test. Simply try doing a cargo test. And yes, it basically works. The position is ordered here. I do not know how to feel about it. So let me check all the collections we have, right? Uh, and for each collection, so let's say singleton is position ordered. I think so. So for empty, uh, is bool ordered is a question, right? Uh, I think uh, is bool ordered in rust. Mm, bool. That means false is considered to be less than true. Okay, so I guess for singleton, false should be the start is false and end is true. So we are on the right path, right? Uh, it is currently ordered. So that is nice. Hmm. Now, mapped, I guess for mapping, the order is exactly the same. Empty orders there, reversed orders there. I guess I want to go and check optional and end is true and start is self dot is sum. So it can be true or false. So miraculously, we have written it such that option and this are ordered. Array is ordered, range, uh, right? So yeah, range is I do not know about range because the position uh, we increase the position only, so it is ordered. For slice, it is ordered. For vec, it is ordered. So I think I would go for git checkout minus b ordered positions, right? And collection.ord, and I guess in design, random access collection, and for yeah, here we only need to follow ordering, okay, and position. uh, okay, so elements are slice method, associated position, the position associated type is regular as well as ordered, so that is regular, so that it can be uh, cloned and stored, cloned and stored for multi-pass multi-pass traversal, as well as, okay, I need to be on call. So again, we are back. Can be stored and for multi-pass traversal, as well as checked for quality, right? And ordered, so that uh, uh, bounds check are efficient for slices, so that bound checks are possible for slices. See forward. Okay, nice. We do this like ordered positions, right? Now git push origin, this thing, right? And yeah, how are other things, right? Now I go for slice, right? And in the slice, now what we need to do is we have to check slices for uh, ordering. So this if position is less than self dot whole dot from, right, uh, self dot from, yeah, position is greater than self dot to. So yeah, what we do is we do a panic out of bounds access to slice, out of bound access to slice, right? So we split, and if on an split we go before from and after to, we do panic. And pop first, these are the things. Great, 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 great. Now here comes start, and that's fine. I and we. I think even for I, it should not be possible because someone might be accessing the other slice, right? So no, it should not be possible. Uh, so or it should be like it's fine to have it here. uh, Next, distance and all of these are fine. The problem is bounce check when we do at, basically. So the at should be checked, right? Because now we are accessing an element, an actual element, right? So that is needed, right? I guess I can have a bound check function. Um, mm, fn bound check, assert bound check, uh, position, whole position, uh, panics if position is out of bounds of slice, right? And how we do this is I have written panic here, right? Assert, hmm, right? Asserts bound check, and is out of bounds of slice, right? And now I do another panic, and I'm like, okay, self dot assert bound check, right? Mismatch type, uh, this, this, okay, and now here at method, right? So we go here, right? We are like, okay, assert bound check of I, right? And yeah, assert bound check of from and to, right? So we do have assert bound check and 20, right? And I guess for the position ones, I am not currently doing that because I feel it's fine, right? But for others, I'm doing it. Hmm. So slice mute. and we again take an assert bound check thing, right? And hmm, right? And what you do is again, uh, for example, here split at and split at, right? What you can do is you can have a bound check. Similarly, for split at mute, you can have a bound check as a bound check, right? And we do put a bound check like everywhere, right? So split and split at mute are done, right? The good thing is here we do bound check on I, right? And yeah, here we do bound check on from and to, right? And yeah, we apply bound check for uh, lazy collection, and we apply bound check for swapping, right? And we apply bound check for slice mute, right? And at last we apply bound check on at mute, right? So this is how we do that. We access these things and bound check, uh, I guess there are few bound checks. Okay, there is a problem with this. Assert bound check, assert bound check, read, right, and slice, and slice. Position is out of bound of slice for reading. Uh, for reading element, right? One slash for uh, defining uh, defining for defining subslice, for defining subslice, assert bound check slice. Okay, and here you basically put a bound read to slice after bound slicing to slice, right? And yeah, that is an impact. Now I do have assert bound check, but here it's slice, right? Similarly, this one is a read one. This one is a slice one, right? Because we basically slice, right? And this one is a read one, right? And that's it. Uh, and we basically copy it out, assert bound check, right? uh, and this is a read one. Okay, this is a slice one, right? This is a read one, right? This one is a read one, right? This is a slice one, right? And this is a read one. So that is the case. Like now we panic if we read out of bound and yeah, split at mute. This is a slice one, right? Because we define the slice like that. So this is a slice one, and that's it, right? Right. So if I see, let's say assert bounds check. So split at is for slice, and these are the methods. So for reading, you want, if it is even at 2, you do not want it to read. Same goes for here, right? Assert bound check on read, at is read, from and to are for slicing, right? So that's nice. And yeah, that is nice. I am thinking if from is greater than 2, uh, again we do like panic, right? uh, but yeah, I can ask for from is greater than 2, and yeah, for now I would not panic there, right? So the good thing is in the documentation, I can actually say where I had to say from and to were the thing. I can say, okay, from is greater than 2, right? Because now from to 2 actually makes sense. It's comparable. So for slice, yeah, assert bounds, right? Assert bounds, compute at is at read one, and I guess we are back again here. Now here, for split at it's slice one, split at mute slice one, assert bound check read is the one, the two, check. So at is read one, and this is slice one, right? Compute at is uh, read one, and I and j, these are for right, slice one, right? uh Swap, these are read ones. What was the other one? Compute at is read one, this is read one, this is read one, and the slice is of course slice one, and admit is read one, right? So this is how you do it, right? uh, and let's see what happens if we run a cargo test with this full thing. Does that cargo test works? Let's see if we panic somewhere. And no, we do not, because we were doing it right? Now, added bound check for slices. And now because we do have bound check for slices, what we can do is, this was the motive, right? uh, now what we can do is we can basically have a slice right here, and now we split at mute, right? So here we do split at two things, right? This one and this one, and this can go for thread T1, this can go to process in thread T2, and this is actually safe concurrency. Why? Because if someone having someone uh, is a T1, right, and they can they're trying to access uh, this slice data but with index of T2, right? So that would have been a data race, right? That would have been a data race, but not now, because T1, if we do that, it would assert in the bound check, and that's it. That's all, right? So yeah, I would go and create a PR for the same, and we'll see for the documentation later. uh, we are doing great, right? uh, Save concurrency with ordered position uh, when uh, two when a slice is split into two slices, they can be processed into different threads. Now for ensuring safe concurrency and no data race, we need to ensure that slice 2 cannot be slice 2's elements cannot be accessed from slice 1, and that happens through bound check here. If out of bounds if out of bounds access happens, uh, the implementation panics, and that is a way, right? That is a way. So the good thing is now I understand the nature of the why is positionless algorithm so necessary, right? uh, I don't know. Yeah, why is positionless algorithm so necessary? The reason for that is positionless algorithms. I don't know if I get the PR, uh, if I get the credit for this PR today or tomorrow. Uh, yeah, it's one, right? So, oh, we do feel some PR linting and things. Why we are we feeling cargo FMT? Oh, assert bounce check read. Where is that? This is in slice.rs. Slice.rs. Oh, wow. And slice mute.rs. Slice formatting. Right. Yeah, we do that. And with positionless design, you do not need to actually do this bound check, because uh, you basically cannot uh, you basically cannot uh, uh, access one slice from other, right? Because there is no concept of positions. So yeah, that was the case. And yeah, that's all from this PR. We'll do some documentation part of this PR coming, and I will discuss this PR today in the Hilo meeting. And after that, we'll discuss the comparison of this one with uh, high-low positionless design approach, right? And we'll see what we can take forward, right? So yeah, that's all from my side for today. And thanks for watching if anyone did. And yeah, bye bye.